This is GPT-4, the device which will change our understanding of what modern technology can do. It will have 100 trillion parameters, which is 500x the size of GPT-3. The company OpenAI was born to tackle the challenge of achieving artificial general intelligence, an AI capable of doing anything a human can do. Such technology would change the world as we know it. It could benefit us all drastically if used adequately, but could become the most devastating weapon in the wrong hands. That's why OpenAI took over this quest. To ensure it'd benefit everyone evenly, the company's goal is to advance digital intelligence in the way that is most likely to benefit humanity as a whole. However, the magnitude of this dilemma makes it arguably the single biggest scientific enterprise humanity has put its hands upon. Although all the advances in computer science and artificial intelligence, no one knows how to solve it or when it'll happen. Some argue deep learning isn't enough to achieve AGI. Stuart Russell, a computer science professor at Berkeley and AI pioneer, argues that focusing on raw computing power misses the point entirely. We don't know how to make a machine really intelligent, even if it were the size of the universe. OpenAI, in contrast, is confident that large neural networks fed on large datasets and trained on huge computers are the best way towards AGI. Greg Brockman, OpenAI's CTO, said, "We think the most benefits will go to whoever has the biggest computer." And that's what they did. They started training larger and larger models to awaken the hidden power within deep learning. The first non-subtle steps in this direction were the release of GPT and GPT-2. These large language models would set the groundwork for the star of the show, GPT-3. A language model 100 times larger than GPT-2, at 175 billion parameters. GPT-3 was the largest neural network ever created at the time, and remains the largest dense neural net. Its language expertise and its innumerable capabilities were a surprise for most. And although some experts remained skeptical, large language models already felt strangely human. It was a huge leap forward for OpenAI researchers to reinforce their beliefs and convince us that AGI is a problem for deep learning. OpenAI believes in the scaling hypothesis. Given a scalable algorithm, the transformer in this case, the basic architecture behind the GPT family, there could be a straightforward path to AGI that consists of training increasingly larger models based on this algorithm. But large models are just one piece of the AGI puzzle. Data stopped being a bottleneck when the machine learning community started to unveil the potential of unsupervised learning. That, together with generative language models and a few-shot task transfer, solved the large datasets problem for OpenAI. They only needed huge computational resources to train and deploy their models, and they'd be good to go. That's why they partnered with Microsoft in 2019. They licensed the big tech company so they could use some of OpenAI's models commercially in exchange for access to its cloud computing infrastructure and the powerful GPUs they needed. But GPUs aren't built specifically to train neural nets. The gaming industry developed these chips for graphic processing, and the AI industry simply took advantage of its suitability for parallel computation. OpenAI wanted the best models and the best datasets, and they also wanted the best computers chips. GPUs weren't enough. Many companies realized it too, and started to build in-house specialized chips designed to train neural nets. However, a pure software company like OpenAI can hardly integrate hardware design and fabrication. That's why they took another route, using third-party AI-specific chips. Here's where Cerebrus Systems enter the scene. This chip company already built the largest chip ever to train large neural networks in 2019. First, Cerebrus has built again the largest chip in the market, the Wafer Scale Engine 2, WSE2. It is 22 centimeters on each side and has 2.6 trillion transistors. In comparison, Tesla's brand new training tiles have 1.25 trillion transistors. Cerebrus found a way to condense computational power efficiently, and so WSE2 has 850,000 cores, the computational unit. They also solved the heating problem with a novel cooling system, and also managed to create an efficient I/O flow of data. There aren't many uses for ultra-specialized super expensive mega-powerful chips like WSE2. Training large neural networks is one of them. And so Cerebrus talked to OpenAI. From talking to OpenAI, GPT-4 will be about 100 trillion parameters. that won't be ready for several years. Since GPT-3, there's been a lot of expectation around OpenAI and its next release. Now we know it'll come out in a few years and it'll be extremely big. It'll be more than 500 times the size of GPT-3. You heard that right, 500 times. So, what can we expect from GPT-4? 100 trillion parameters is a lot. To understand just how big that number is, let's compare it with our brain. The brain has around 80 to 100 billion neurons, GPT-3's order of magnitude, and around 100 trillion synapses. GPT-4 will have as many parameters as the brain has synapses. The sheer size of such a neural network could entail qualitative leaps from GPT-3 we can only imagine. We may not be able to even test the full potential of the system with current prompting methods. However, comparing an artificial neural network with the brain is a tricky business. The comparison seems fair, but that's only because we assume artificial neurons are at least loosely based on biological neurons. A recent study published in Neuron suggests otherwise. They found that at least a 5-layer neural network is needed to simulate the behavior of a single biological neuron. That's around 1,000 artificial neurons for each biological neuron. But even if GPT-4 isn't as powerful as our brain, it sure will leave a few surprises. Unlike GPT-3, it probably won't be just a language model. Historically, the role of robotics in space exploration has been massive, due to the unlivable conditions of non-terrestrial planets in the solar system. Before scientists began sending robots to space, animals such as dogs or monkeys were often sent to complete tasks and conduct experiments, in order to increase human knowledge of conditions on other planets and the Moon. As robotic technology has improved, more of these experiments and tasks have been delegated to robots, rather than to living beings. In this way, robotics preserves lives. While humans have set foot on the Moon, scientific knowledge of conditions on planets including Mars, Venus, Titan and Jupiter comes almost exclusively from exploration conducted by robots. With the recent advancement in humanoid robots, the need or practicality of sending humans to space now seems illogical. NASA have already displayed their astronaut robot in the past, but I think they realize they can outsource the most advanced humanoid robots from Boston Dynamics, with robots such as Atlas and Spot. Now the GOAT himself, Elon Musk, CEO of SpaceX, is sending a humanoid robot on the next SpaceX mission. The S1 robotic arm tech demo, designed by space robotics startup Gitai Japan Incorporated, will demonstrate the versatility and dexterity of a robot in microgravity. The mission will research projects dedicated to exploring everything from astronauts' bone and eye health to the dexterity of robots and how plants handle stress. It will also include an experiment dedicated plant growth, ant colonization, and the brine shrimp life cycle. Designed by a group of Girl Scouts from Central Florida, the U.S. Space Agency confirmed. When searching for signs of life on other planets, scientists say caves are a crucial place to look. But how can a team on Earth effectively explore intricate, dark, unfamiliar landscapes on another world? NASA and Boston Dynamics have found an answer: fully autonomous robots. The research could fundamentally change how we think about future missions. Is now in year 3 of 4 in its quest to journey to the Moon, the Red Planet and beyond. Future potential human exploration missions can benefit from robots in many different ways, particularly robots can be sent in precursor missions to provide more information about the destination before humans land on those destinations. In addition, robots can accompany astronauts during the missions to help with scouting certain terrains or with logistics and many tasks. It's possible that next-generation robots could access areas of Mars that would not be capable with traditional rovers, such as the Perseverance or its predecessor, the Curiosity. Next-generation robot bodies and mechanical locomotion capabilities would enable new types of missions over terrains that were otherwise inaccessible by traditional rovers. Also, due to the increased speed and traversal capabilities of these robots, will mean future missions can target destinations that are traditionally considered to be too far from landable regions on Mars. So, a 3D printed house, built in under a day, sound inconceivable? Well, it's not a start to a sci-fi drama, but a real company tackling this massive feat. So sit back, relax, and let's take a glimpse into the future of real estate. Icon has used 3D printing, so far, to create homes that could end homelessness in America, to work on off-world construction, on the Moon or Mars, and to build military barracks. As you can see, the sky's the limit on what this company can theoretically produce using 3D printing, robotics, software, and advanced materials. Icon uses a proprietary cement-based material. That might explain the reason Icon has experienced 400% revenue growth almost every year it's been in business. The company Icon, located in Austin, Texas, has just completed a Series B funding round of $207 million, led by Norwest Venture Partners. Other investors in this round included 8VC, Bark Ingalls Group, BIG, Bond, Citi, and more. Icon isn't the only company creating 3D printed buildings, and in fact, it isn't behind the first ever 3D printed house sold in the US either. That distinction goes to SQ4D, another company that develops 3D printing construction systems. SQ4D created a 1,500 square foot 3-2 home situated in Riverhead, New York, which sold for more than its $299,999 asking price. However, Icon did create the first permitted 3D printed home in the US, a 350 square foot home that took only 48 hours to complete, at 25% speed. But that house never sold. While several companies already occupy the 3D printing space, at 3 years of age, Icon is a known player in this new industry and is ready to scale, said the company's CEO Jason Ballard. The ability to construct 3D printed homes is a massive leap in this technology, a true disruptor in the housing industry. Theoretically, homelessness could be wiped out not just in America but also around the world. In Russia, for example, Abiskor built a 3D printed house in less than a day, with the total construction cost being just over $10,000 for a 410 square foot house. Icon has already built more than 24 3D printed homes in the US and Mexico, more than half of which are for the homeless or people living in poverty. Icon teamed with developer 3 Strands to build mainstream housing in Austin called the East 17th Street Residences. The Austin homes have 2 to 4 bedrooms and are supposed to be more resilient to natural disasters. These homes have a 3D printed ground floor and a traditionally built second floor. They range from 1,000 to 2,000 square feet in size and cost about $450,000 apiece, which is about what comparable homes in the area are selling for. Future plans include projects with NASA to create habitats on the Moon and Mars. Icon has began 3D printing an analog habitat, designed by BIG at NASA's Johnson Space Center, to help prepare for long-duration human missions to Mars. The Crew Health and Performance Exploration Analog, or CHAPI, is a sequence of 3 one-year Mars surface mission simulations at the NASA Johnson Space Center in Houston. Each will have a crew of 4 individuals isolated together in Mars Dune Alpha, the 3D printed habitat created by BIG. Crew tasks may include participation in scientific research, use of virtual reality and robotic controls, and time delays in communication. The results from ground-based missions like this help NASA prepare for the real-life challenges of space exploration. NASA has begun its recruitment and applications to participate as crew are being accepted through mid-September 2021 for the 1-year analog mission that starts in fall 2022. So guys, if you're interested in seeing what it's like to live on Mars for a year, then head over to NASA's website to apply. 3D printed homes have the potential to increase the housing supply, decrease the cost of homes, increase the speed at which houses are built, and produce homes that are more resilient to extreme weather conditions. Icon plans to use the funding from this Series B round to build more 3D printed homes and to undertake more research and development. This is GPR1. It's a general-purpose robotic avatar, designed to help its human pilot accomplish a diverse range of tasks. Sanctuary's mission is to democratize work, with labor-as-a-service general-purpose robotic avatars, making it possible for anyone to do any job from anywhere and at any time they choose. We are making work safer, more accessible, and ultimately more productive. Using cutting-edge technology and artificial intelligence, cognition, and robotics, the startup company are delivering immediate customer value with labor as a service. From agriculture to energy, healthcare to logistics, retail to construction, and everything in between, on this planet or any other planet, the possibilities are literally out of this world. Now let's take a deeper look and let the guys from Sanctuary AI show what the robot can do.
Fantastic.
Oh, that was a good one. Where?
Here.
Right here?
Here.
This is Richie. The robot is an expressive open-source humanoid platform programmable with Python. He is particularly good at interacting with people. You can take control of Richie remotely wherever you are, and test any application in any environment, immediately. With its brilliant program software, you can teach the robot how to perform advanced tasks using a VR kit. Back in 2013, Pollen Robotics started with Poppy, the first 3D printed open-source humanoid robot, and since then they have been dedicated to creating open source, open science and open data products. They work with scientists, artists and innovators to explore usages, and make the robotic revolution an available opportunity for everyone. Here are the key features of this incredible humanoid robot. Open source hardware and software. 7DOS bio-inspired arm with modular gripper. Expressive head animated by our unique orbitospherical joint. Software based on ROS2 with Python SDK. Dual 1080p at 30 fps camera with motorized zoom, FOV 65 degrees to 125 degrees. Powerful internal computer Nuke Intel i3 dual-core 2.1 GHz with 8GB DDR4 and 256GB SSD. The company released the first version of Richie at last year's CES. Remember? That was before most of us even knew COVID existed. To illustrate this, they made it play tic-tac-toe at CES and it was quite a success. We all know that many robots are providing bridges to ROS but without really pushing the integration deeper. The company let you use all standard ROS tools with Richie, with a focus on manipulation, as this is why Richie has been designed for in the first place. This package contains the relationship between all links and joints of the robot, including their joint limit properties as loaded from the URDF. It is used by all visualization and trajectory planning tools in ROS. They also provide inertial and mass values. The collision model is defined with simpler shapes as cylinders, so you can achieve accurate and fast simulation. Of course, 3D models of the robot's parts are also present. MoveIt is a motion planning framework, It runs on top of RAWs and provides functionality to make manipulation easier. Within this package, you will find all the configuration files needed to start using Move It with Reachy and plan complex trajectories. A Zacro file has also been written to define which groups are used, depending on the version of Reachy you use, advanced, expressive, or basic. Could AI robots replace farmers and make agriculture more sustainable in the near future? Robots powered by super artificial intelligence could farm more sustainably than more traditional agriculture methods, claims one Silicon Valley company. Agricultural technology startup Iron Ox says that its mission is to make the global agriculture sector carbon-free. And they have just secured $53 million in funding from investors including Bill Gates. CEO Brandon Alexander can't be accused of lacking experience when it comes to food production. He spent every summer of his childhood on his grandparents' farm, picking cotton, potatoes, or peanuts under the Texas sun. Yet, with a degree in robotics precisely to escape farm work, Alexander says he couldn't budge the feeling that he could have a bigger impact working in agriculture. A feeling that only grew when he learned that 40% of food grown worldwide is chucked away before reaching our shopping baskets. Alexander left his previous job in 2015 to take a 6-month road trip through California. He wanted to find out firsthand what problems American farmers were having and figure out how automation could help. Along the way, he learned about extreme water scarcity, difficulties of finding labor, and a whole host of other issues. Armed with this knowledge, Alexander launched a startup company focusing on autonomous farming in 2018. To really eliminate waste, to really get to that next level of sustainability and impact, we have to rethink the whole grow process, Alexander explains. Now, in the company's greenhouse in Gilroy, California, 2 robots named Grover and Ada grow basil, strawberries and other crops. Iron Ox's system uses artificial intelligence to ensure each plant gets the optimal levels of sunshine, water, and nutrients. Grover is in charge of carrying the plants to the dosing station, where it hands off the produce to Ada, a robotic arm. His stop is akin to a doctor's visit. Sensors help to check the water for nutrients levels and any other ingredients needed for healthy growth. After the examination, customized doses of nutrients can be automatically delivered to the plants through the hydroponic system. This way, the farm produces less waste and uses only the amount of water it really needs. Data is continuously collected from the crops, helping the AI learn what the plants need, improving their yield, and reducing their environmental impact. There is a critical mass of innovation and momentum in robotics right now, with people ever more being replaced by robots. Smart, autonomous, mobile, humanoid robots capable of taking on multiple complex tasks will be everywhere within 5 to 7 years. One of the biggest fears about robots is that they will take all the jobs. Even if a robot is replacing just 2 minimum wage workers in the US, a robot's price point of around $200,000 will be ROI positive within 3 years. To put that price tag into perspective, you could already buy the spot inspection robot from Boston Dynamics for $75,000. Because manufacturing has largely moved offshore, the tipping point for robot adoption in the US will be when robots are able to perform and are accepted in service jobs. Once they can do that, we will see a dramatic adoption of robot labor. Over the last few years, global growth and the COVID pandemic have created a supply/demand imbalance and a labor shortage. If that continues or the global demand for goods and services grows even more, the addition of professional service robots will have only positive side effects. Robot labor will replace and displace human labor sooner than you know. Any redundant workers will be quickly re-employed into new jobs created by the growth. If, for some reason, demand stagnates or declines, human workers will likely be replaced by robots at a greater pace than they can find new jobs. Higher unemployment levels will result. Counterintuitively, the cure for this will be more robots. When personal service robots reach a price point equivalent to a car, the consumer market will explode. Historically, consumers have adopted other initially high-priced, but desirable labor-saving devices extremely rapidly. When they do, the increase in leisure time these devices create leads to a host of business and employment opportunities and jobs that fill that extra leisure time with entertainment, travel, games, and hobbies. Robots can work in environments and do things that we can't. They are physically stronger, less fragile, have more stamina, can work in dangerous conditions, don't need mandatory breaks or safety precautions, and won't sue their employer, strike, or demand more pay. Things that were previously impossible because of the physical, legal, or financial risk, but will now be possible. Construction, exploration, commercial fishing, farming, and transportation will all see massive productivity gains and cost reductions. Entrepreneurs will immediately identify new markets and opportunities that can be opened using robot labor that were previously impossible, or at least financially impractical before. So, yes, robots will take some jobs, but they will also create tremendous economic growth, increase leisure time, and improve living standards across the board. So I hear you ask, where do that leave your jobs and income? This is why I encourage you to start that side hustle online, or the dream business, because jobs will soon be obsolete. Thanks for watching. Drop a like, guys.
Oh.